Hi, my name is Prakash Gupta, and for my oral presentation, I'm going to tell y'all a little bit about manufacturing technology, computing devices for creation. So in this presentation, we're going to discuss three different types of device, and that's 3D printers, CNC machines, and laser engravers. These are all different manufacturing processes and devices. So first, let's talk about what manufacturing is. So from Oxford Dictionary, it is to make or produce something in a mechanical way. And that is a really broad description. It applies to almost every product that we interact with, something that you buy at the store, the computer that you're watching this on, a toy. Everything's pretty much manufactured, especially anything that's made in a factory, because those are of the same root. So let's jump right into it. 3D printing. So this is a process that's used to fabricate 3D objects and models. And these can be designed by individuals, or you can find some on the internet and print them yourself. It's often an incredible, powerful tool for prototyping because you can make your design, print one out. If it's not up to the standard that you want, make your edits to the design and print another one. It's really quick and really powerful in that means. It's especially good for prototyping because it works exclusively, not exclusively, but almost exclusively in plastics. So if you want to create something, the typical 3D printing material is PLA. I actually have a printer off screen over here, so that's why I'm looking that way. So it's also super useful for teaching design in the same reasons that it's good for prototyping, because as your students create their own 3D models and learn to design, we can print them out and they can see tangibly the relationships between what they create and what it actually comes out as. 3D printers are often present in makerspaces, universities, high schools, and libraries nationwide for public and institutional access, but they're also often affordable enough for hobbyist use, and they range in price from a few hundred or 800 to thousands. So let's look at some pictures. These are some common 3D printers here. There's a hobbyist one, the Creality. That's actually the one that I have. There's the Bamboo, which is a new upcoming brand that's very efficient. Over here is a scientific printer that actually uses multiple materials at the same time. You can see 4 different spools. Additionally, up here we've got some different 3D printed objects. These are some bowls and shapes and vases and things. And it just shows some versatility. Actually, like right here off on my desk, I've got some 3D printed fidget spinners and geared toys. So I also want to look at this graphic down here. So 3D printing works by pushing coils of plastic through this PTFE tube down to the extruder where it's heated and melted, and then pushed through as the end moves to leave lines, and it builds them up, as you can see on the dragons that are over here. So now we're going to jump into laser engraving, and that involves the use of a laser, to emboss, engrave, print, burn, etch, or create generally on 2D planes. It's less affordable because lasers are more expensive, but it also enables working with metal because you can engrave on metal and on wood. These are typically less complex to operate because they're two-dimensional, and they're differing from regular printers, only in the need to dictate speed and power, which is important because if you have a laser and you use it on full power, it might catch your wood piece on fire, where you might need it to be on full power to cut metal. You just have to know the materials that you're working with and the specs of your machine. This is also important because you can use regular graphics when you laser engrave. Down here by me, there's a laser engraver that we keep in my shop at school. And then around, there's just some different products that you can make. Metal name tags, metal plaques, all sorts of wooden designs and signs and nameplates and stuff like that. It's very versatile. Moving into CNC machines, CNC stands for Computer Numerical Control, and these devices use designs and individually user-built programs to fabricate and cut material on large scales. This is the most commercial and used most often in factories, and these machines can be massive, several, even dozens of square feet. You can work with plastic, metal, and wood, and these use drills to cut. And they can also use plasma. You can see some pictures here. This is a pretty standard mid-size CNC machine. Over here in the center is where the drill bit would go, and it gets spun by the machine, of course, to cut. These pictures have got wood, so you can cut things like signs, or you can cut mechanical parts to build like a chair, stuff like that. So let's talk a little bit about how computing goes into these machines. And it's an important and massive part of these devices and these processes. Something important to talk about is G-code. G-code refers to the programming language interpreted by these devices, and it is generated by the operator, either written by hand or it's procedurally generated by assistive software. And that contains the step-by-step instructions for the machine, and that varies, of course, by different devices and different brands. So that means for a 3D printer, it means setting the temperature of the nozzle, because different plastics need different temperatures. For a laser, that means setting that power. For the CNC machines, it means setting the drill speed. All sorts of different things, and every individual task has to be programmed for. Each machine also has its own operating system, and that's just because every machine pretty much has an operating system that allows you to interact with it, and as you see, read and make adjustments. And it also interprets that G-code to the physical actuations and motors. So let's talk a little bit about how operators are going to use computers and computing. And that's mainly in the design process, and that's different for all three. So let's talk a little bit 3D modeling. You've got different software like AutoCAD and SketchUp that are for technical design and components. And you have some more animation centric things like Blender. And these will generate your 3D models. You can make the shapes and designs that you want in here. After that, you want to export them and take it into a slicer, which will process that model and make the G-code we were talking about. To create engravable graphics, you can just make any kind of graphic. In Adobe Illustrator is what I like to use. But there's also, PowerPoint even, where you just make what you want and then export it as a graphic, an SVG. And then you can generate that G-code in any kind of printing application for some printers, or some special software like Lightburn for other more industrial types of engravers. CNC machining is a little more complicated because you have to create your design just like an engraver, but then you also have to do vector manipulation because it's important that everything's connected and concise on a CNC machine because of the dangers of a spinning drill bit. After that, the software that you use, be it like Autodesk Fusion or VCarve, is going to create toolpaths. So you decide what gets cut and what gets engraved, and then it's going to generate that G-code. Moving on, we're going to talk a little bit about the implications of manufacturing processes like these. So I think it's important to discuss on two different scales. One, there's the world industry manufacturing scale, which uses processes like these to create the products that we use in everyday life. I mentioned that earlier. One thing that I'd like to say, so if you ever walk into like Marshall's or you want to go buy something to paint, any of those wooden cutouts that you can paint or buy for like dollars at the dollar store even are made on laser engravers, and you can tell because they have scorch marks on the sides of them. So that's just like a real world application of how laser engraving gets used in industry. And I think it's important for us to know about these processes so that we know what makes and how things are made. It's also important on the small scale because it's empowering to be able to create something. Like, I think that's very fundamental to the human experience. And being able to design something in your head or envision a 3D model and then design it and create it and then hold it in your hand, that's an incredible feeling. It's also important, on the educational standpoint of teaching engineers, creating engineers. They have to know how things are made to design things to be made. It's a very important part of the process, in the engineering process. It also teaches you how to use these devices in your own inventing and creating journey. When you have knowledge of manufacturing, you're able to actually invent things, not just think of them or design them. you could actually go and cut out the metal components that you need to build your robot, or 3D print the holder that you need to mount the shelf that you want, and all sorts of little things like that. So I think manufacturing, again, is the power of creation, and these devices and their computing power enables that for us. Here are my works cited, and thank you so much for your time and for listening to my presentation. And a note about the fact that my Wi-Fi is down and there might be some issues uploading. Thank you so much.